All right, so let's say I ask you to come up with what polonium-218 is going to turn into if it undergoes alpha decay. Now you'll notice that one thing different here is that polonium-218 doesn't have the atomic number I gave you. Usually we'll give you the atomic number, but just in case you're not given the atomic number, Rodolfo, just in case you're not given the atomic number, you can always look it up. So polonium is right here. And that's atomic number 84. Right? So you can always look up the atomic number. The atomic numbers will always be the same for any isotope. Remember we talked about that last week? It's the mass number that can vary. Right? So you have to be given the mass number. Otherwise you won't know what isotope of polonium it is. But polonium always has an atomic number of 84. All right, so polonium-218 undergoes alpha decay. How are we going to figure this out? Well, you just do this. The mass number is going to be subtracted by 4, and the atomic number subtracted by 2. So let's take 4 off of the mass number. We're going to go from 218 to 214. And then the atomic number is going to go from 84. We subtract 2 from it. We're going to go from 84 to 82. So we're going to get a new atom here with an atomic number of 82 and a mass number of 214. Now the question is, what element is it? And if we look it up on the periodic table, what's atomic number 82? Atomic number 82 is lead, Pb, lead. So that's where we get our symbol. Okay. So see how I get the numbers first, then I look up the symbol? Once it's done, it looks like you knew what element it was, but really it was the atomic, changing the atomic number, then I looked up the symbol. And then I write that it's a, we get an alpha particle at the end. Okay? Any questions on this? What? Yeah.
How do we know how many neutrons and protons?
How do you know how many neutrons and protons you have? Well, the number of protons is right here. And
how can we subtract this 4?
okay, so that's what I was going to say. That's what is asked. Why do we subtract 4? Why do we subtract 2 here? Because that's what's going to be on the alpha particle. Right? So we had this one right here. We had this atom, and we got rid of 2 protons and 2 neutrons. Right. So total atomic mass of 4. Total mass number 4 that we lost in the alpha particle. So now since we took this off of this, now we're going, okay, well, what's left over? And that's what our new atom turns into. Okay. Let's do another one. Because I want you guys to see, it doesn't matter what you start off with. If it's alpha decay, it's always done the same way. Let's say we have uranium-234. Uranium-234, and this time I'll give you the atomic number of 92. Once again, just like we did before, we subtract 4 from the mass number, subtract 2 from the atomic number. So 234 minus 4 is 230. 92 minus 2 is 90. Okay. Everyone good with that? Subtract 4 from this number, you get that. Subtract 2 from this number, you get that. Now all I have to do is look up the element that has atomic number 90. So you got atomic number 90, it's right here. That is thorium, right? All right, so TH thorium, and we also have the alpha particle. Okay. Once again, we subtract 4 and 2 because that it's alpha decay, which means it's going to lose an alpha particle. And note that your mass numbers on the right of the arrow equal the mass numbers on the left. 214 plus 4 is 218. And 82 plus 2 is 84 here. Same thing over here. 230 plus 4 is 234. And 90 plus 2 is 92. Okay. Any questions on either of these alpha decay? All right, let's do a beta decay one. So, put this line here. Below this line is beta decay. All right, let's say we had lead 214. Okay, now this lead 214 here is not stable, but it undergoes beta decay instead of alpha decay. So what's it going to turn into? Remember, for beta decay, you leave the mass number by itself, and what you're going to do is add 1 to the atomic number. Because remember, our neutron is turning into a proton, so we're getting 1 more proton, but the number of protons plus neutrons is staying the same, because we lost a neutron, but we gained a proton in its place. So now we're going to end up with an atom with mass number of 214, but an atomic number of 83. Now I got to look up what atomic number 83 is. Yes, 83 is Bi, bismuth. Right, so the symbol we'll use is Bi. Plus, in this case, a beta particle. Remember the symbol is E with a -1 atomic number and 0 for mass number. Or you could also have put 0 and -1, a beta. One or the other, one of these two will work. Once again, note that our 214, the mass number, was just transferred over. We didn't change it. And the atomic number went up 1. Different from the alpha point, the alpha decay. Questions on that? One last one. Because these are all big, but even the smaller ones. Let's say you have nitrogen 16. Nitrogen 16 also undergoes, let's say, beta decay. So, once again, leave the mass number alone, add 1 to the atomic number. And we're going to end up with a particle with mass number of 16, atomic number of 8. What has atomic number 8? Oxygen. Good. Number 8 is oxygen, so we're going to turn it into oxygen 16. Okay. And here I'll put it as a beta particle here. Once again, you can do either one of these. They're the same thing. An electron and a beta particle are the same thing. Okay? So that's how you're going to do the problems. And your problems on your worksheet are just like these. Let me go ahead and show you. Hold on, let me stop this here.